Okay, so here we go on practice exam number 4. So the first question, random sample of 300 women, 45% favored stricter gun control legislation. Random sample of 200 men, 25% favored stricter gun control legislation. Construct a 98% confidence interval for the difference in population proportions. Let's go look at our exam 4 notes. Oh, here's some good things to add to your exam 4 notes. For two proportions, you could put this HO, H1. Not for this problem, but just in general, it'll be helpful to add to your notes. And for two independent means, this HO, H1. For this particular problem, we're talking about two proportions. And we're doing an interval, so it's 2 prop Z interval. So 2 prop Z interval, because, see, it's population proportions, 2 populations, and it's an interval, a confidence, 98% confidence interval. So we go there on our calculator. 2 prop Z interval, and it asks you x1 in 1, x2 in 2. So now what are those? Well, the 300 women, that's the n, right? Because, and then the 200, that's the other n. Because n is always the total number of people. 300 women altogether, 200 men altogether. Now how do we find the x value? Well, that's 45% of the 300. 135. And this is 25% of the 200, which is 50. We can see that on the exam 4 notes, number 1. It says, if a percentage is given, like 32% of 500, then x is 32% of 500, or 0.32 times 500. So that's what you have to do. So that's how we find the x value. Because for the 300 women, 45% of them is 135. 45% of is multiplying. 25% of 200 times 200 is 50. So put those numbers into your calculators. And the C level, the confidence level, is 0.98, as they said right here. And what do we get when we do those numbers? We get 0.10233, comma 0.29767, and that's none of the above. So there's the answer, but it's just not there. All right, let's go to number 2. Number 2. The table shows the number of households burglarized in a sample of households with dogs and a sample of households without dogs. Do the data support the claim that a smaller proportion of households with dogs are burglarized? Okay, well, let's focus on the words that came after claim. There it is right there. Do the data support the claim? What claim? That a smaller proportion. This is about proportions. P1 and P2. Now, look down here at the table. Households with dog, households without dog. So P1 and P2. We just take them in the order in which they come in the table. P1 first, households with a dog. So this is the dog households, this is the no dog households. And what's the deal there? The proportions with a dog are less, aren't they? The households with a dog are less. That's what it's saying. The percentage of burglaries in households with dogs is lower than the percentage of burglaries in households without a dog. Right? The claim that a smaller proportion of households with dogs are burglarized. So the dog proportion that's burglarized is less than the no dog. That's what's being claimed. That's the claim. Okay, so we write our HO and our H1. So HO is always that they're equal. H1 must be the less. Right there, the claim. Okay, and then now from here, where are we going to go? Let's go see the exam notes. So here we are, two proportions, HO, H1. So we go to the 2 prop Z test. So 2 prop Z test. And when you go to the 2 prop Z test on your calculator, you get X1, N1, X2, N2. So that's going to be, here's our X1 and our N1. N is always the total number, right? So 21,208, X2, N2, 15,126. X1, N1, X2, N2. And the percentage is, well, we're supposed to do less than. We're supposed to do the arrow is less than. So let's put those numbers in our calculator. And I calculate, I get a p-value equal to 0.3027, which rounds to 0.303. There it is. There's the p-value. On to number 3. Now number 3, paint manufacturer made a modification to a paint to speed up its drying time. Independent, simple random samples of 11 cans of type A, the original paint, and 9 cans of type B, the modified paint, were selected and applied to similar surfaces. The drying times were recorded. All right, so notice A is original paint is A, and B over here is modified paint with the chemical, the new special chemical they're trying to put in the paint because they want to make the paint dry faster. So the chemical is in there to speed up the drying time. All right, so they're saying find a 98% confidence interval for mu1 minus mu2. So let's go to our exam 4 notes, and we're looking for mu1 minus mu2. Here's the mu1, mu2 stuff is over here, so it must be number 2, because here's all the HO and H1 and the mu1, mu2 stuff. So we must need, because there's no proportions, notice, right? In this question, there's no percentages, but there's averages, aren't there? There's no percentages, but there's averages. So we need to do a 2-sample T interval. It's an interval, confidence interval, not a test. So we need to do that. So 2-sample T interval. Go to 2-sample T interval on our calculator. See why it's interval? Because we're doing a confidence interval, not a test. And we'll hit stats, and then basically put in all this information right there. So X1 is 76.3, S1 is 4.5, N1's 11, X2 is 65.1, S2 is 5.1, N2 is 9, confidence level 98%, pooled is always no, calculate. So whenever they ask you for pooled, you always say no. All right, so here's the confidence interval I'm getting on my calculator. 5.6, I'll say, to 16.8. Both are positive. So they ask me, what does the confidence interval suggest about the population means? What does it mean when you have this kind of a confidence interval? Well, if we think about it, that means that if you did like a number line, here would be 0, here is 5.6, here is 16.8. So we are in this zone, right? The confidence interval, we're 98% confident that we're somewhere between 5.6 and 16.8. Those are both positive numbers. So we're confident that we have a positive answer. Positive answer to what? mu1 minus mu2. Remember, that's what it's always about. We're subtracting two numbers. So if you subtract two numbers, in fact, let me bring this over here. If you subtract two numbers and get a positive answer, what does that mean? Remember, we're taking the difference between the drying times, paint A and B. We're taking A minus B, and we're getting a positive answer. Right? Because it's between two positive numbers. What does it mean if you subtract two things and get a positive answer? Like 7 minus 2 is positive 5. That means the first one is bigger, meaning A is bigger. A is bigger, right? If you subtract two things and you get a positive answer, like we're getting a number between positive 5.6 and positive 16.8, a positive number. Both these are positive. That means, how can you subtract two numbers and get a positive answer? Only if the first number is bigger. So the A must be bigger. So A must be bigger than B. Okay, great. What does that mean? Well, A is the original paint. So the original paint. And the B is the modified with the chemical. So what does that actually mean to us about real life paint and chemicals and stuff? Well, notice the B, if it is smaller. This one's smaller, this one's bigger. Right? As we say right here, the first number's bigger. If you're subtracting two things, right, the whole key is our confidence interval came out with two positive numbers, which means we are between two positive numbers, meaning the answer is positive to the difference between A and B. That's what this is all calculating, is the difference between mu1 and mu2, which is A minus B. And we're saying A minus B is coming out to be a positive answer. That means A is bigger. The only way to subtract two things and get a positive answer is if the first number is bigger. So the A is bigger, the B is smaller, which means the chemically modified paint, B, is coming out with a smaller time. Smaller time. Well, that's perfect. That's what we want. We want the chemically modified paint to come out with a smaller time. So that's what it means. That's what this confidence interval is telling us. You can see all that on the exam notes, number 4 right here. Notice it says right here, the meaning of a confidence interval. If all are negative, it means one thing. If all are positive, if one's negative, one positive, we have all positive on our confidence interval, which means 0 is not included and implies that mu1 is greater than mu2. That's what we said. Right? A is bigger than B. Mu1 is bigger than mu2. A is mu1, B is mu2. Right here. Mu1 minus mu2. Mu1's bigger. A is bigger. So what does that mean in words? Well, let's try it. The confidence interval includes 0. Does it include 0? No, 0's out here. No way. The confidence interval includes only positive values. Yeah. But this one says that, and so does this one. Got to read on. Which suggests that the mean drying time for paint A is smaller. Yeah, that's wrong. A is bigger, huh? So that's wrong. Which suggests that the mean drying time for paint A is greater. Yeah, A is greater than the drying time for B. The modification seems to be effective. Yes. The other one says doesn't appear to be effective, or no difference. That's wrong. So there's our answer. It's effective. It reduces drying time. B, the modified chemical, B is coming out smaller. So it's working. There we go. All right, so let's go to number 4. This one says a researcher was interested in comparing the resting pulse rates of people who exercise regularly and those who do not exercise regularly. Independent, simple random samples of 16 people who do not exercise regularly and 12 who do exercise regularly were selected, and the stuff's recorded. So this is do not, and this is do exercise regularly. All right, well, is this one about percentages or is it about averages? It's clearly about averages, isn't it? This is an average, this is an average. There's no percentages anywhere. Let's go back to our exam notes. So it must be number 2 here because we're talking about 2 independent means, not proportions. It's not number 1 with proportions. So we're either going to do 2-sample t-test or 2-sample interval. Is this one a hypothesis test or a confidence interval? Let's see. This one is test the claim. Oh, there's a claim. In fact, let's write that claim. What is the claim? The mean, so that's average, resting pulse rate of people who do not exercise regularly. Which group's that? This, let's call this mu1, and this group's mu2. Just take them in order. The do not is mu1. So the mu1, the do not exercise regularly, and the mu2 will be the exercise regularly. So which is true? The mean resting pulse rate of people who do not is larger. The do not is larger. That's the claim. So HO is that they're equal. H1 is that mu1 is greater than mu2. All right, and so now we go on from there, and we go into our calculator, 2-sample t-test. That's what it tells us back here. On this one, HO, H1, we'll do 2-sample t-test. So let's try it. So I'm going to do 2-sample t-test. And I'm going to choose stats. Because we don't have data, we have stats. Basically, these stats. Put those in. X1 is 73, S1 is 10.9, N1 is 16, X2 is 68.4, S2 is 8.2, and N2 is 12. And this is a what, greater than problem. And pooled is always no, calculate. So I'm getting a p-value that is 0.107. There it is, 0.107. So we got it. There we go. That was a 2-sample t-test.